Okay, the recording has started. So as mentioned, today we are going through the 2016 paper 3. All right, so let's turn to question 1. Now, question 1, I'll just go quickly through this. Now, the first question of the O-levels is always this kind of question, where it's a one-word or one-letter answer. So this is actually quite similar to your prelims, where we ask you to suggest the pieces of apparatus used to measure certain things, to separate certain things. So first, the keyword here is pieces, which is to say that the answer may not just be one word. It could be multiple pieces of apparatus. So take, for example, 1A part 1, separating a precipitate from a solution. Obviously, the keyword here is precipitate. You should know by now, precipitates are solids. All right, they are insoluble. So how would you separate insoluble solids from a mixture? You would always use filtration. But here, the answer is not filtration. They want the pieces of apparatus. So what apparatus do you need for filtration? It is not just filter funnel. You also need the filter paper. All right, so you should write both in. You need both the filter funnel and the filter paper in order to separate a precipitate. All right, next, part 2, measure exactly 22.7 cm cube of solution. Now, exactly, another way to put it is accurately. All right. Now, if it's accurately, you need to use either burette or pipette. Then you look at 22.7. 22.7 is a clear-cut clue to you that you need to use a burette. Why not a pipette? Now, pipettes is only for 25.0 cm cube. Only 25 cm cube use a pipette. All right. Now, this is tricky because that year, most students thought, oh, but burette is 2 decimal places, right? 22.7 is only 1 decimal place. Well, don't get tricked. The question may give you 1 dp, but you are expected to know that 22.7 is a volume that only a burette can measure. All right. Next, collect and measure the volume of a gas. A measure volume of gas, this is gas stream. Finally, the last one, add exactly 25 cm cube of solution. 25 cm cube is a key hint to you that is a pipette. Okay, so the first question, 4 out of 4, just naming apparatus, we should be able to score 4 out of 4 where possible. Okay, so if you are lost, you can go back to the summary that I did on chapter 2, the measurement techniques, and go back there and revise all these again. Okay, let's go quickly through to question 1b. The apparatus shown in the figure can be used to separate pure water from seawater. Again, highlight the keywords. The keywords are always the chemical names. Pure water, seawater, these are chemical names. So once you know it's to separate pure water, immediately you know it's separated by the method called simple distillation, or distillation for short. All right. So that's why it's important to highlight keywords. When you highlight keywords, you immediately know what the question is about. Then you won't go out of point, you won't think of the wrong things. So the method shown, obviously, this method shown is called simple distillation or distillation. Okay, so for completeness sake, let's write simple distillation. Okay.
Mr. So, I read distillation is completely fine also, right?
Yes, but for completeness sake, as we go through, let's write simple distillation, okay? Next, what's the reading on the thermometer? Again, this is where highlighting keywords is important. If you know it's pure water, you will know that pure water boils at 100 degrees Celsius. Degrees Celsius is important, okay? Must have units. Okay, next. State the purpose of the water in the condenser. So in 2016, many students got confused. Because in class, they have learned the purpose of the condenser, but they have not learned the purpose of the water in the condenser. But actually, isn't it the same? You are pumping in cold water into the condenser so that the condenser can perform its function, right? So asking you about the purpose of the water is the same as asking you the purpose of the condenser, which is to cool and condense the vapor or the gas to form a pure liquid distillate. All right, so this is the purpose of the condenser. It is also the purpose of the water in the condenser, all right? Okay.
So,
Yes.
if I put to form liquid only?
No, let's be more specific and say that it's to cool and condense the vapor. All right. All right, moving on to part 4. 2 samples are taken. This is the hardest part. So this is a typical O-level question. It may start off easy, but maybe the last part is a bit harder. Doesn't mean that it's hard, you leave blank. You think through it. How do you think through it? Highlight keywords. The keyword is point A, point B, of course, right? Because point A and point B are different things. And what do you do with it? You place it in an evaporating dish and you heat to dryness. This is important. Heat to dryness means what? All the water evaporate. That means your answer, whatever that's left behind in each sample is not water. Water is gone, evaporated. So you are told that sample A will leave a white solid. Oh, white solid. Whereas sample B had no residue. Why? You got to explain it, right? How do you explain it? So let's go back to the diagram. Point A, this is obviously seawater, right? You started with seawater, you heated it. Seawater contains what? Obviously contains water, but it also contains sodium chloride, right? Seawater is basically salt water. It will contain water and sodium chloride. So what happens when you evaporate this to dryness? The water is gone, leaving behind sodium chloride as a white solid, right? So that explains part of the observation already. That's 1 mark already, right? A is seawater, which contains dissolved NaCl. When heated to dryness, the NaCl is left behind as a white solid. That makes perfect sense. Salt is a white solid, right? Now, but this alone will not give you 2 marks. So always think about the examiner's marking. How will they give you 2 marks? They will only give you 2 marks if you have 2 points. This is 1.1. You only address A, but now you're going to address B. So now if you look back at the diagram, B is right at the end where you collected the pure water, right? B is pure water. Why is B only pure water? Because only the water will boil and distill off at 100 degrees Celsius. That's why it's pure water, because only the water will boil and distill off. All right. So when heated to dryness, there is no solid left. It's only water. There's no solid, right? So when you heat to dryness, there's nothing left, just nothing, because all the water has evaporated. Okay. Okay, so that was question 1. Okay, if you are okay with question 1, can you give me a thumbs up so that I know you are done? Then we move on to question 2. Now, question 2 is also an important question. Okay. Okay, great. Now let's move on to question 2. Now, question 2 is a typical O-level question. All right, where we give you the number of protons, neutrons, and electrons. Now, it is very important, okay, to listen up carefully. Where do you start first when you're given data like this? You should always start from the proton number first, because this will tell you which element it is. The proton number will determine what the element is. You need to know what the element is, or else you will not be able to answer the questions correctly. You will make careless mistakes. So how do you do this? You use proton number, you go to the periodic table. So for example, if it's 1 proton, the element is hydrogen. If it's 3 protons, the element is lithium. If it's 7, nitrogen. 8 is oxygen. 9 is fluorine. Immediately you realize which are the isotopes, right? Okay, even without getting to the question, you already know they are the isotopes, because isotopes are atoms of the same element. So just go down the list, you already realize that F and G are isotopes. Because they are atoms of the same element, with the same number of protons, but different number of neutrons. All right, so you can see this is very powerful. Always start with the protons and find the element. Next, don't go to the neutrons, go to the electrons. Because you know that if the proton and electron is the same number, it's an atom. So if it has the same number of protons and electrons, it's an atom. However, if the proton is less than the electron, it's a negative ion. If the proton is more than the electron, that's a positive ion. So now you have to go down the list and see whether it's an atom or an ion. So once you do that, you realize that the first one is an atom. Second one is the positive ion. The third one is atom. Fourth one, fifth one also atom. And the last one is a negative ion. Now this is a problem-solving technique, please. You need to have this problem-solving technique. Regardless of how simple the questions are that follow, please have this technique. Why do I say this? Because you will really hate yourself if you get this wrong. The way to do it correctly is to work out the element and to work out whether it's an ion or an atom. All right. And with that, you realize that you can answer part C very easily, right? An ion of a metal, metal, ion, metal. Isn't it D? The lithium ion. Next, an atom with 5 electrons in the outer shell. Isn't that group 5? Group 5 will have 5 electrons in the outer shell, right? Isn't it nitrogen? Finally, mass number 18. Mass number is proton plus neutron, right? So proton plus neutron 18, that will be G. And there comes the next reminder that I want to remind you of. They never said that each letter can only be used once. They didn't say. So if they didn't say anything, you assume that each letter can be used more than once. All right. So as you can see, the letter G is actually used twice. It's the answer to part A and part D. So please don't make assumptions. Read the instructions carefully. This is what we went through when we talked about 2012 and 2013 as well. All right. So I'll just leave. Oh, sorry. I'll just leave this here for a while for you to copy. Just give me a minute. Let me share the screen again. All right. Okay, I shall leave the screen on for you to copy for a while. Just make sure you take everything down and learn how do you do such problems. Now, you will realize that a similar problem occurred in 2018. So this is 2016. 2018, a similar problem appeared. So hopefully you learn the problem solving strategy. All right, so after this, right, let me just go through. Let me just skip to question 4. So I'll skip question 3. We will go straight to question 4. So the questions that I skipped I'll also put the answers onto OneNote later on, so please make sure you also go through it yourself. Okay, the reason why we are skipping is so that we can spend more time on the questions that I think are a bit more challenging. Okay, so I shall go to question 4 now. Question 3, by the way, is on periodic table. So if you have forgotten periodic table, again, go back to the summary that I've given you. Okay, you can also rewatch the video lesson that we did that day. All right, but let's go to question 4 now. Question 4 is not super hard, but because it requires you to plan an experiment, like briefly plan an experiment or describe a test. Now, most students didn't know how to do this that year because they didn't realize how to determine the most reactive of the 3 metals. Okay, now you are told that only one of these metals is above hydrogen. This is an important sentence. It means that only one metal will react with acid, right? So hopefully you recall anything above hydrogen in the reactivity series will react with acids, which means that you can just use any acid to tell which metal this is, because only one of them will react with acid. The other 2 are below hydrogen, they won't react with acid. So all you need to do now is to place equal masses of each metal into, say, 5 cm³ of dilute sulfuric acid. All right. Then once that is the case, the metal that produces effervescence is the most reactive metal. Okay, you just need to observe which one will give you effervescence. Effervescence means it reacts with the acid to produce hydrogen gas. Okay, so that's part 1. Now, part B, describe a chemical test that will show the presence of copper-2 ions. So this is QA, right? Going back to QA. Now, this is not difficult. I'm sure you know how to test for copper-2. So for example, you can add aqueous ammonia. You know that aqueous ammonia, aqueous NaOH can be used to test for copper-2 ions. However, if you just write add aqueous ammonia, no marks. Why no marks? Because when you describe a QA test, you need to be specific. You need to tell the experimenter what to do. You add aqueous ammonia drop-wise until it is in excess. This is the standard QA instructions that you see in your practical test. So you should also follow the same method. All right. So you don't just say add aqueous ammonia, you need to say add aqueous ammonia drop-wise until it's in excess. Then this alone won't get you 2 marks either, right? This is only 1 mark. You need to tell me what's the observation. If there are copper-2 ions, what do you observe? A blue precipitate will be formed, and the blue precipitate is soluble or dissolves in excess aqueous ammonia to form a deep blue solution. Can now, so this is how QA was tested in 2016. Then you must be wondering, I thought QA is always the flowchart question. Well, 2016 is one of those years that they didn't have a QA flowchart question. 2016 is one of those years where the QA was organic chem. Okay, so besides aqueous ammonia, you can also use aqueous NaOH, okay? But obviously, aqueous NaOH observations are different. because you will get a blue precipitate form, and the blue precipitate is insoluble in excess aqueous NaOH. Okay, so please write correctly. Okay. Now, as mentioned, so 2016 was one of those years that the organic QA came out. So we are going to go through organic QA later to ensure that we know how to do it. All right. Now, my Sec 5s in 2019 told me, come out in 2016 already, won't come out again. Well, 2019 O-level was also organic QA. Okay, so those Sec 5s that I thought would study it generally did quite well, right? So must study organic, okay? Can. So 2016 organic QA. Actually, 2012 also organic QA, right? I think. Yes, the previous time we went through. Yeah. Then 2019 also organic QA. All right. Okay, moving on.
Hey, sir, can show just now. I never copy finish.
Okay, copy first, copy first.
Okay, finish already.
All right, so question 4 is done. Now question 5, let's go to question 5. Now question 5, the difficulty is not part A, okay? Part A, as you can see, the O-level combined science, they really love grams per dm cube, moles per dm cube. So if you don't know how to convert between grams and moles per dm cube, it's a problem. All right. Now, actually, they have given you a lot of info already. They've given you the relative atomic mass, relative molecular mass of 98. So the MR is 98. They have told you that. All right. They have given you 200 cm cube, 196 grams of J. So first, to calculate concentration in gram per dm cube, all you need to do is take 196 divide by 200 cm cube. Remember, you need to convert cm cube to dm cube. With this, you will just get 980 grams per dm cube. All right. Can? So that's grams per dm cube. Just taking the grams divided by the volume in dm cube. Remember to convert cm cube to dm cube. The problem now is, how do you then convert to mole per dm cube? Well, gram per dm cube, gram. How do you go to mole? You divide by the MR. Okay, so you divide by 98. That gives you 10 moles per dm cube. All right. So this part shouldn't be the challenging part, so long as you have learned the conversion. The challenging part, and actually the most difficult question, or one of the most difficult questions in 2016, was actually B part 1. Okay. So B part 1 really tests your knowledge of QA and whether you actually bothered to highlight keywords. So the keyword here is when J is mixed with acidified aqueous barium nitrate, a white precipitate K forms. So they asked you, why can't K be barium carbonate? Okay, so most students just wrote that, oh, because barium nitrate is a test for sulfate, therefore the white PPT is barium sulfate. That's not the point. Okay, the point is acidified. Okay, barium carbonate is also white and it's also insoluble. So in theory, barium carbonate could precipitate out because it's insoluble as well. But because it's acidified, barium carbonate would have reacted with the acid. In acidified barium nitrate, right? Because it's a carbonate, it will react with acid, right? To form a salt, CO2 gas, and water. So it will not precipitate out. It reacts with the acid to form a soluble salt, CO2 and H2O. So it will not precipitate out. And this is the reason, if you recall when I first taught you QA, this is the reason why we always add nitric acid at the start, then aqueous barium nitrate. Same for silver nitrate. You must add nitric acid first. The whole idea of adding nitric acid first is to react away any carbonate ions, to prevent the carbonate from precipitating out. Okay, so this was the most difficult question in 2016. So you might want to put a star next to it. This is actually the reason why you must add acid first before barium nitrate or silver nitrate, okay? So what is K? So now that you know K is not barium carbonate, because barium carbonate will have reacted with acid, right? So what is the white precipitate? K is barium sulfate. Okay, which you are familiar with because QA you have always learned barium nitrate is a test for sulfate. The white precipitate is barium sulfate. All right. So J is sulfuric acid. How you know it's sulfuric acid? Question never say, you know. How do I know that J is sulfuric acid? Because you know that it contains sulfate, it's an acid. So which acid contains sulfate? Only H2SO4. Okay. Okay, so it's plus barium nitrate, aqueous forms barium sulfate, solid, plus HNO3 aqueous. Then you must be wondering, why is it not an ionic equation? I thought precipitation is an ionic equation. No, they want the chemical equation with state symbols. So you give what the examiner wants. They don't want you to give the ionic equation. They want you to give the chemical equation. Now, how are the 3 marks given? The 3 marks is given. First 1 mark is formula correct. That means you have written H2SO4. You have written BA bracket NO32 correctly. The next 1 mark is the balancing. Do you balance it correctly? For example, do you put a 2 in front of the HNO3? The third mark is state symbols correct. Okay? Now, this is combined science O-level. The equation with state symbols is always 3 marks. That's why it's important to write equations correctly. Next, how do you know it's HNO3 form? Many students don't know. Always ask yourself, what ions are present? You have sulfate, you have barium. Barium and sulfate form the precipitate. So what is left? What's left is the H plus and nitrate. H plus and nitrate form HNO3. Okay? Can? Now, I know this is not easy to write the equation, but you need to try. All right? You cannot leave 3 marks blank. Even if you think you won't get it right, you try. And by now, we should be able to write the formula of acids. H2SO4, HNO3, HCl should be familiar to you. You should be familiar with common ions like carbonate, nitrate, sulfate, hydroxide. All right? These are things that you must revise. I've given you a laminated periodic table for a reason. These are all on the laminated periodic table. You need to look at it every day, memorize it. Okay? So that's question 4 and question 5. Now let's go to question 6. Now question 6, right? I'm just going to quickly go through it, especially part A and part B. Okay, part B actually. All right, so let's move on. Now, question 6. Many students just ignore the first part, okay? But you need to read. Now, this reaction is highly exothermic. What does exothermic mean? I'm sure you know by now. Exothermic is not difficult. I think you all know the answer. Exothermic means the reaction releases heat energy to the surroundings. You need to write to the surroundings, okay? Don't just say it gives out heat. Okay, a lot of you like to write things in short sentences. I have no idea why. This is your O levels, make it work. Give full details, releases heat energy to the surroundings. Now, part B is also difficult because you have never learned clean energy before. But they have actually given you a hint, right? Even if you didn't know what clean energy was, they told you that the burning of hydrogen is a source of clean energy. That means burning hydrogen is clean, whereas burning fossil fuels is not. So you're asked to suggest the meaning of the term clean energy. So obviously it has something to do with hydrogen burning. How is hydrogen burning different from burning fossil fuels? Fossil fuels, we have learned. If you burn fossil fuels, you will form CO2 and H2O, right? Complete combustion gives you CO2 and H2O. Whereas burning hydrogen gives you what? So this one never learned before, right? But you can predict, right? Burning means hydrogen reacts with oxygen. That's the meaning of burning. So it forms water. Okay. So the only product is water. So now you look at it. Hydrogen burns, gives you only water, whereas fossil fuels will give you CO2. Then you think, so what's so different? The difference is that fossil fuels gives you CO2. Is CO2 good for the environment? No, right? So you have learned carbon dioxide is responsible for the greenhouse effect. It causes climate change and so on and so on. So now let's bring this together. So what is clean energy? It's clean if energy produced from sources that do not release atmospheric pollutants. So remember, we learned about air, right? We have atmospheric pollutants. So clean energy must be from sources that do not release atmospheric pollutants. This one not 2 marks, huh? You must go on. For example, hydrogen burns to produce only water, which is not a pollutant. Okay, so that's hydrogen. Fossil fuels, though, so your hydrocarbons like alkanes, alkenes, the hydrocarbons in your fossil fuels burn to form CO2 and H2O. And CO2 contributes or causes climate change. So it is not clean energy. Okay, we can do this. All right. So again, this is difficult. Okay, I admit it's quite difficult. Okay, I mean it's not something you've learned before, but you got to think about it and don't leave it blank. Actually, you think about it, right? Most of you will at least get 1 mark out of 2 if you try to write something. You should always try. All right. So please don't be thrown off course and panic just because one part is difficult. Honestly, it's 2 marks. If you write something, you might get 1 mark at least. Okay. Okay, so every year there's one question like this, okay? 1 or 2 parts like that. If you look at your TYS, every paper will have 1 or 2 parts like that, okay? All right, Ken. Now, for 6C, 6C, sorry, 6C is more concept, okay? I shall take the liberty to go through it really quickly, okay? So I'm just going to quickly run through it. All All right, so are we ready to go on to 6C? Can you give me a thumbs up if you are ready? All right, let's move on. All right, so first we have the relative formula mass. Relative formula mass is basically MR. Okay, the first one is 204. Please show working. Make sure you show working. All right. Now, as you can see, for combined sets, actually they do help you. They give you the ARs of the elements on top. You just needed to realize that it's there. Okay. Next. So always is finding MR, then finding number of moles. Convert to moles, right? So whenever you do something like that, you must convert to moles. The 1,000 grams of hydrogen. So the number of mole of H2 is 1,000 divided by 2 times 1, which gives you 500 mole. All right. Then you use mole ratio. In this case, you need a mole ratio of H2 to firelight, Fe2SiO4. So you go back to the equation. It's 2:3. All right. So 500 mole is to 750 mole of firelight. So what's the mass of firelight? Is 750 mole times 204. Okay, it's a huge number, but take note, just make sure you copy out correctly. Now at this juncture, right, okay, as you copy down the answers and the solutions, to be really honest, this is a standard mole concept problem. You just need to convert the quantities to number of moles, use the mole ratio, and then finally, after the mole ratio, find out the answer that you want. However, can you please be careful with units? Over here it's easy because everything grams. Grams is what we need. You need to use grams when you sub into the mole concept equations. Those taking physics, you must remember this. Because chemistry and physics are different. Chemistry always gram. That means if you see kg, you must convert to gram first. For physics, all the equations require kg. So for example, in physics, you all learn F equals to ma. Density is equal to mass over volume. In physics, all these equations use kilograms. Chemistry, gram. All right, need to know this. Need to remember it's gram. If we give you kilogram, convert to gram. Okay, I said it so animatedly so that you will remember. The last thing I want is people coming out of the exam hall realizing, I forget to convert kilogram to gram. So other units, we also got other units like tons. Also must convert to grams. We will give you the conversion. But kilogram, you must know. 1 kg is 1,000 gram. That one you must know. Okay. Same as volume. Volume, you must use dm cube. All right. So units are important. Chemistry, gram. Chemistry, dm cube. All right. All right, volume of 1,000 grams of hydrogen. So again, just now we calculated, right? You must convert to moles first, okay? Number of moles of H2, 1,000 grams divided by 2, that gives you 500 mole. 500 mole, what's the volume? 500 times 24. Okay. That gives you 12,000 dm cube. It's a huge number, right? All right, so take note, units, very important. All right. And then we go on to question 7. Now, question 7 is the main reason why we have to revise this paper. I strongly advise you to revise question 7, even after today. All right. So can I move on? If I can move on, give me a thumbs up so I know you're done. Okay, Ken. So I hope I've instilled in you the importance of units. Chemistry, gram, DMQ, gram, DMQ. All right. Moving on. Now, this is what I meant by organic flow charts. All right. So you must be like, oh my God. But actually, this is very easy. If you have studied organic chem, this is like ultra simple. All right. The problem is most students in 2016 didn't prepare for organic chem QA like this. They had prepared for the usual QA flowchart. So a learning point that I really want to drive home to your class is that please don't spot questions. It's now not the time to ask what will come out. What do you think Cambridge will test? The time has come for you to study everything. All right. Now, if you notice, when I taught your organic chem, I actually taught you the MRs of common substances. And that's because I knew that it was tested in 2016. This is an organic question. You know it's organic chem because it's hydrocarbons. The keyword here is hydrocarbons. All right. Which means that hydrocarbon must mean either alkane or alkene. All right. Hydrocarbon must be either alkane or alkene. That means L and M must be either alkane or alkene. That's the first thing. Okay. So if you recall, hydrocarbons are compounds that contain only carbon and hydrogen only. So alcohols are not hydrocarbons, okay? Alcohols got oxygen. Carboxylic acid got oxygen, so they are not hydrocarbons. Hydrocarbon must be alkanes or alkenes because they only contain carbon and hydrogen atoms. Next, I'm not sure if you realize, in your syllabus for combined science, we can only test you alkanes and alkenes that have 1 to 4 carbons. That means we won't test you something that has more than 4 carbon atoms, okay? So this is important for this question because what you're given is the MRs of L and M. So how do you know what compound are they? Well, first, got to ask yourself, how many carbon do they have? From the MR, you must be able to trial and error and think how many carbons there are. For example, if I tell you 28, each carbon is 12. If the MR is 28, how many carbon do you think it will have? Well, if it's just 1 carbon atom, that won't be enough to make 28 because 1 carbon is 12. The mass is 12. If I want to make 28, what's the nearest? 2 carbons, right? If I have 2 carbon atoms, the mass will become 2 times 12, which is 24. You know it's a hydrocarbon, so it must have hydrogen, right? The whole MR must be 28. If I got 2 carbons already, 2 times 12 is 24. 28 minus 24 equals 4. So 4 hydrogens. Okay, so L is C2H4. M is 1 carbon, 4 hydrogens. This makes an MR of 16. All right. Ken, so based on the MRs, I actually can work out what they are, right? So once you know the formula, the next step is of course to work out the name. CH4 is methane, so it's an alkane. C2H4 is ethene, alkene. All right. Now, this is important because once you work out what L and M are, the rest are easy. But if you don't know what L and M are, you're just working in the darkness. You don't know what's going on. And therein comes the main point of today's lesson. For organic chem, What are the useful MRs to learn? This is for organic chem. The first MR to learn is 16. 16 is methane, CH4. All right. The next useful MR to learn is 28. 28 is ethene, C2H4. So that's alkene. The next useful MR to learn is 30. That's ethane, C2H6. The next useful MR to learn is 42. That is propane, C3H8. Oh, sorry, C3, sorry, not 42, 44. C3H8. Finally, the last one that I think is quite important, 46. 46 is ethanol, C2H5OH. Okay, so let's take down these 5 MRs and what they are. Okay, so now, of course, if you are already finding it difficult to learn organic chem, maybe the MR is not very high on your priority list to remember, but learning it does help, all right? Okay, especially the alcohol, 46. All right, so now that you have copied the MRs, let's go through the flow chart. So now you know L is ethene, M is methane, just based on the MRs. So how do you do it? You always start with carbon. How many carbons do you think it would have? Then you work out how many hydrogens it has based on the MR. Okay, important skill to learn. Now let's go through reaction by reaction. So let's go in the order that is given to us. So let's start with N. N comes from L, C2H4, right? N comes from L. When L reacts with bromine, alkenes react with bromine. What kind of reaction is this? If you know that it's alkene, it must be an addition reaction, because alkenes undergo addition, right? So what is N? N must be addition. Addition means you don't remove H, you just add on the bromines. But how many bromines do you add in? The answer is 2. Okay, so this one is where I scare you with the name. So firstly, L is ethene. Now you can write the formula, you need not name it, because actually if you look at the question, they just say suggest the identity. So you could just write the formula. So L is ethene, N is 1,2-dibromoethane. Did Mr. So teach this? Yes, it's in the alkenes notes. All right. Now, the 1, 2 is important to show that the bromines are on the 2 different carbon atoms. So 1 bromine per carbon atom. All right. Now, but minimally, you must write dibromoethane. All right. Now, M is methane. All right, let's just fill it in. Now, how do you draw 1,2-dibromoethane? It looks like this. So you can see it's 1, 2 because it's on a, on a different carbon atom, right? The bromines are attached to different carbon atoms. So it's 1, 2 dibromoethane. Now, minimally, you must write dibromoethane. All right. So the 1, 2 means the 1 is for the amount of. The 1, 2 refers to which carbon atom is on.
Mr. So,
Then wrong. Yeah. Yes, correct. Yes.
for this part A, right, do I have to write the chemical formula or I just write ethane can already?
You write either one. So you either
Oh.
write ethene or C2H4.
Okay.
All right. Now, so we have solved N. So now let's do O. Now, O comes from M. M is methane. Methane reacts with chlorine gas, right? But this is obviously not the same as just now. This is not addition, this is substitution. Because alkanes undergo substitution. Alkane substitution. Remember, we went through this. ACS, alkane, combustion and substitution. Then you have ECA, alkene, combustion and addition. All right. So this is methane A substitution. So what does substitution mean? Substitution means your hydrogen, 1 must go away. Then 1 chlorine goes in. Okay, so this one got name also. O is CH3Cl, that's called chloromethane. But if you don't want to write the name, you're scared you get it wrong, you write the formula. So only the addition has the 1, 2 because you need to show which carbon atoms is on. Don't have. Because we don't put dihydro something. Yeah, it's a naming. Okay. Okay, I have some students in front of me, that's why I'm answering the questions, okay? So if you come to the library, of course, I'll also answer your questions there and then on spot. All right. Now, so you realize that from L to O, it requires good knowledge of organic chem. Okay. To be really honest, if you study organic chem, you know addition, you know substitution, you can work it out. But I must admit, when this came out in 2016, students were very shocked. Okay, but 2016, we didn't have TikTok yet, so students couldn't go on the TikTok to complain about the paper, but people were shocked. Actually, is it really that difficult? The answer is no, right? If your knowledge of organic chem is good and you have studied what we told you to study, you will be able to do it so long as you remain calm. So that's what I'm encouraging you to do. Please study organic chem and please ensure you remain calm. Knowing things like addition, substitution is very important. All right. So if you are lost, always go back to the alkanes and alkenes notes, go back to the summary notes, then ask also. We have gone through organic chem summary 4 times already. So it's important to know this well. All right. Now we have not solved everything yet. We are left with P, right? Now P is a mixture of 2 substances, and P is formed when it burns in excess air. So this burns in excess air is a key word. It tells you what reaction it is. It's not addition. It's not substitution. Burning is complete combustion. Because you know it's complete combustion, you can easily work out what P is, because complete combustion of alkanes and alkenes will give you only carbon dioxide and water. Of course, you can write the name, okay, carbon dioxide and water. Okay, so water or water vapor is fine, but make sure you know what is complete combustion. Complete combustion is when something burns in excess air, excess oxygen, and it only produces 2 things, carbon dioxide and water. All right. So with that, writing the equation, I think is quite straightforward. Just choose any equation. I'm just going to randomly choose something. Sorry. Yeah, you can write substitution, you can write addition. So I'm choosing to write combustion because that's something that I remember. All right. So with that, let me just keep this for a while so that you can copy down. All right. Okay, once you're done, can you give me a thumbs up so that I know you're done? All right, so we are now going to move on. Question 8, I will not go through. Why? Because question 8 is inside your metals notes, part 3. When we did blast furnace, we went through this question already in our notes, metals notes, part 3. So if you are lost, please go back to OneNote, look for metals notes, part 3. That's where question 8 is. All right. Now I want to go through question 9. Now, question 9 again is organic chem. You can see that organic chem does feature quite heavily pre-COVID. And I want to remind you, your batch is the first batch that has organic chem in the O levels. It's not removed. You have learned organic chem thoroughly. You should have revised it thoroughly as well. So now let's look. 9A part 1. Ethanol can be made in a lab at room temperature. Name the process, list what's needed, and write the chemical equation for the preparation of ethanol. So we have gone through this before. To prepare or manufacture ethanol, the process is the fermentation. Fermentation is used to produce ethanol. Now this is 1 mark. All right, what are the substances needed? The substances needed or the raw materials, okay, are yeast, glucose solution. Okay, many students remember yeast, but not the glucose. You need to remember glucose, okay? You need to first have glucose solution or else there's nothing to ferment, right? Now, the substances needed actually is just yeast and glucose solution. Okay? Then you must be wondering, hey, where's the temperature? Where's the absence of oxygen, right? Mr. So has gone through this before. Yes, those are not substances. Those are called conditions. The conditions needed are 37 degrees Celsius and absence of oxygen. Okay. Now, you realize that actually, right, this question doesn't require the conditions. That's not one of the things that the question wants. Okay. Nonetheless, let's just write it in for completeness sake. Now, this question, do you really need to go on to talk about, oh, we need to have absence of oxygen so that the ethanol will not oxidize? Do we need to talk about why 37 degrees Celsius? The answer is no. If you look at the question, they are really very targeted. They just want the name of the process, which you have named it already. The substances needed, which you have named it already. The last part is just writing a chemical equation, all right? So you really don't have to go on to elaborate for this type of question. When do you go on to elaborate? You elaborate when they ask you to describe, sorry, I spelled it wrongly. Describe or explain the process of fermentation. The keyword that you're looking out for is describe, explain. If they ask you to describe and explain, then yeah, you must elaborate. Why 37 degrees? Why absence of oxygen? How come the yield of ethanol is only 15% at the end? Because ethanol in high concentrations will kill the yeast, right? So that's called description, that's called explanation. So if they ask you to describe or to explain, then you go on to elaborate. But this question don't need. They are not requiring you to do that. All right. So learning to read the keywords in a question is very important. So now with the equation, it's very straightforward. Okay, you must start off with yeast and glucose, right? C6H12O6. This is glucose. You have yeast, 37 degrees, absence of oxygen, and it will form ethanol, C2H5OH, and CO2 gas.
Mr. So, for the
Yes.
glucose, right, is it C5 or C6?
C6.
Or C6?
C6H12O6. Okay, NFS students, I expect you to memorize this well, right? Glucose is a simple carbohydrate, it's a monosaccharide. Yeah, we know that, right? NFS? Yes, we know that, right? Okay, now this equation obviously is difficult to balance, so please try to learn it by heart. As you can see, even I try to learn it by heart because I will take some time to actually think of how to balance. So I would learn such equations by heart where possible. Okay, especially if they are difficult to balance. All right. Okay, so I just asked a question. Is it okay that your equation is like cutting across the dotted lines? Yes. Okay. So long as it's on the paper, in the space given to you. Okay. So please, don't need to squeeze everything into one line. Don't do that. Okay. Make sure that your handwriting is legible, can be read clearly. Okay. Now, next, state why the temperature must not be allowed to rise much above 45 degrees. So the bio students will find this easy, right? We have mentioned before. Yes, okay. You cannot allow it to rise above 37, in fact, because this is to prevent the enzymes in yeast from denaturing. So we mentioned before, the optimum temperature for enzymes in yeast is 37. Above 37, the enzymes will denature, meaning the enzyme will change shape, it will no longer work, and it will no longer be able to speed up fermentation. So the word here is denaturing, is to prevent the enzymes from denaturing. Okay. Let's not spell it wrongly. Okay. Now, actually, right, this question is not the difficult part. The difficult part that most students got it wrong was part B. Then you must be thinking, why, right? Why would they get it wrong? Now, I've marked this paper a number of times for all my Sec 4 classes. So every single year I have a Sec 4 class, I will mark this paper, and I will always have students getting part B wrong. But why? The reason is very simple. Never highlight keyword. They highlighted organic acid. They highlighted propanol, left open to the air. But they failed to recognize that I want them to draw the structure of propanol. Many students, instead of drawing propanol, they went to draw the acid that was formed. And usually, the students who will make these mistakes are all the A1 students, which was very interesting to me. I don't know why, but they want you to draw propanol, right? They don't want you to draw the acid, right? So I'm drawing the alcohol. So part B, the difficulty was most students drew the wrong thing because instead of drawing the alcohol, they went on to draw the acid. Okay. So once you know it's the alcohol, you draw the alcohol. 3 carbons, draw the 3 carbons first. Draw the functional group first. The functional group is OH because it's an alcohol. Then you just have to fill in the blanks with hydrogen. Can? So that's propanol, right? Now, another mistake that most students make is that they like to write OH, OH, but you must show every bond, right? So you must draw the O-H as well. So this question was more tricky than you think. All right. So actually the next part, right, is easy. Once you recognize the keywords, you roughly know. So suggest the formula of the organic acid. How do you suggest? Actually, right, you can draw the acid out, right? So the acid, if you write it out, is C2H5COOH. Then you'll be like, huh? It's 2 carbons, what? How can it be 2 carbon? I thought propanol got 3 carbon. So remember, Mr. So said in class so many times, carboxylic acid must be careful. Because there is already 1 carbon in the COOH functional group. So outside, right, it must be CN-1. So you must take 3 carbon minus 1 at the outside. So it's C2H5COOH. How do you avoid this? Again, I always tell students, actually you can draw the molecule out, right? Instead of writing C2H5COOH, you could have drawn the whole structure out. That's also formula, what? Drawing structural formula. So actually, I would have encouraged students to do this. Okay, so I would encourage students to draw it out. Drawing out avoids the problem where students forgot that it's C2H5COOH. Many students will just write C3 straight away because they think there is 3 carbons. But remember, there's 1 carbon in the functional group of a carboxylic acid. Best thing to do, draw it out. So has the propanol been oxidized or reduced? Obviously, the propanol has been oxidized. Okay. The simplest way to explain this, of course, is using oxygen. Oxidation states are very hard for organic chem. For organic chem, don't use oxidation state. Okay, use oxygen. Okay, so as again, oxygen atoms to form propanoic acid. Okay, can? So as you can see, there are some careless mistakes here and there. Okay, so try to avoid those careless mistakes. Make sure you really read the question. Okay, and if you have forgotten this was from alcohols and carboxylic acid. So it's time to go back to our notes again and study those thoroughly. Okay, I have 15 minutes more. I want to do question 10. Now, question 10 is worth doing as well. Question 10 is one of those questions whereby students didn't know what to write. The dot and cross diagram is easy, all right? But the next few parts were difficult because most students didn't know how to explain or what to explain. All right, so once you are done, can you give me a thumbs up so that I move on to question 10? All right. So A part 1 easy, H2 should be easy to draw. H2O also I don't think it's very hard. Most of you can do it. By the way, they want you to show all the electrons. In case you forgot, you need to show all the electrons because they never say show the arrangement of outer electrons. So many students, I'm sure, would have forgotten oxygen has 2 inner shell electrons. Okay, so make sure you draw all the electrons, including the inner shell. Okay. All right, so it's 2 marks for each dot and cross diagram. Make sure you draw all the electrons, okay? Because the question didn't say outer shell only. Okay, the problem is not the dot and cross. So I'm going to skip the dot and cross. It's part 2. Most students saw part 2 and just gave up. Again, do you give up when you don't understand? No. You try to understand. You try to write something that's relevant. Explain why knowledge of the electronic arrangements in helium and neon is important when drawing dot and cross diagrams for hydrogen and water. Wow. So if you are really lost, it's something to do with electronic configuration of helium and neon, right? So you try to work it out. What is helium? What is neon? Look in the periodic table. Helium, 2. Neon, 2, 8. So you realize that these are the noble gases, right? They have a fully filled outermost electron shell. Helium is from period 1. Neon is from period 2. That's important because if you look back, isn't that what you have done? Hydrogen shares electrons to completely fill the first shell. Oxygen shares electrons so that the second shell, its valence shell, is fully filled. So the whole idea is hydrogen and helium, maybe they are related. Oxygen and neon, maybe they are related because it tells you how many electrons to share, right? So how do you phrase that into a sentence? Helium has a fully filled first shell with 2 electrons, right? Hence, hydrogen shares 1 electron with another hydrogen atom so that its first shell is fully filled. This is 1 mark. So explaining how hydrogen shares electrons so that it achieves the same fully filled first shell with 2 electrons like helium. Then you must explain for neon. Neon has a fully filled second shell with 8 electrons, right? 2, 8. So the second shell has 8 electrons. So how is this important? Hence, oxygen. You notice oxygen, it must share 2 electrons, you know. Oxygen will never share just 1 electron. That's why it's H2O, right? It's not HO. Because oxygen must share 2 electrons. In order for its second shell to be fully filled. Now, this kind of question is challenging because actually writing it in words is challenging for most students. But you must try, attempt it to the best of your ability. Like I said, even if you cannot get 2 out of 2, you must try to get 1 out of 2. All right? All right, so let's move on to B part 1, part 2. Part 1, part 2, B is very easy. B easy, y'all can do one. All right. Now, B, gaseous hydrogen chloride dissolved in water to produce 2 ions. Huh? So if you just write 1 ion, you don't get marks. You must write both. So what are the 2 ions? It's HCl, you know. The 2 ions are, okay, it's an acid, right? HCl. Acid must have H+. If you got H+, then the Cl must be Cl minus. This is 1 mark. 1 mark for both ions correct. If you have one ion missing, then you get minus 1 mark. The approximate pH is acidic. HCl is strongly acidic, so it should be around 1. Okay, having said that, I will accept answers from 0 to 2. Please don't give me pH 6. HCl is pH 0 to 2 as a strong acid. Try to give whole numbers where possible. All right. Next, part 2. Explain why aqueous solution of HCl can be neutralized by adding aqueous sodium hydroxide. The easiest way to do this is to write this. You have learned the ionic equation for neutralization, right? So basically, the H plus in HCl reacts with the OH minus in NaOH, right? To form water, which is neutral. So whenever you're asked how come something can be neutralized, the best way to start is the ionic equation for neutralization. Then you go on to explain in words. The H plus in the acid reacts with the OH minus in NaOH to form water, which is neutral. Okay. Okay, so now that you have gone through the entire paper, you realize that 2016 actually is not very difficult. It was demanding in a few ways. Organic chem was demanding in 2016. But besides that, learning how to phrase stuff correctly is important as well. So I want you to revise how to phrase stuff correctly. So how to phrase stuff correctly means like part 2. Just now we went through this one, phrasing stuff correctly. Okay. Ensuring that you can phrase things like neutralization correctly as well. In fact, this B part 2 appeared again in 2017 and 2018. 2018, I think, when they asked students, how come ammonia can be neutralized by HCl? The answer is the same, all right, as this. All right, so learning how to phrase stuff correctly is an important skill, which we actually went through in 2018 O-levels as well. Okay, so now let's take a 10-minute break. Let's come back at about 3:35. We will go through 2020 paper. All right, so let me stop the recording here.